This problem is a little tricky. You have to pick up on the fact that since they give us the mass and they tell us that it's silver, we can look up the density. So we should pick up on the fact that this is a density problem. They don't give us the volume, but they do give us 2 out of the 3 things that we need to calculate the volume. And since they tell us what it is, we can look up the density, and the only thing that we're missing is the thickness or the height of the object. So that's what we're actually looking for. We have to use our volume equation, so we know that volume is equal to mass divided by density. We also know that volume is length times width times height. Since both of these things are equal to volume, we can set them equal to each other. So length times width times height is equal to mass divided by density. They give us the length and the width. We're looking for the thickness, which we're going to say is the height. So when we rearrange the equation, we get height is equal to the mass divided by the density, the length, and the width. So how did I rearrange that? Well, since we're multiplying by the length, we have to divide both sides by the length to move it to the other side. So when I divide the left side by the length, it cancels out length. And when I divide the right side, it adds it to the bottom. So we do the same thing to width. We divide both sides by the width. That cancels out your width. And then you're left with height, which is our thickness on the left side by itself. We have all our other variables on the other side. So we end up with our final formula being height is equal to mass divided by density times length times width, all on the bottom. So now we start plugging in our numbers. We know mass is on top, plug in 1.02 grams. So since we're dividing by density, we want to put our density number on the bottom. So the 10.50 grams goes on the bottom. And that makes sense because we want our grams to go away. We want them to cancel. Our density is 10.50 grams per centimeters cubed, which is per 1 centimeter cubed. So we want to put that opposite of it so that we don't have a fraction inside our fraction. This is, remember, one big long fraction. We don't want a complex fraction. We want simple fractions. So I'm going to go ahead and cancel out our grams. So now when I put my length and my width on the bottom, they're both in centimeters. That should cancel out 2 of my centimeters out of the centimeters cubed. So I put one of my dimensions on the bottom. Doesn't matter whether I call it my length or my width. That centimeters is going to cancel out 1 of the centimeters in the centimeters cubed and change it to centimeters squared. Because remember, centimeters cubed is centimeters times centimeters times centimeters. So then we put our last dimension on the bottom as well because we're dividing by it. And that centimeter is going to cancel out our square, and we're going to be left with centimeters, which is what we want. We want a unit of distance or a unit of length. That's what a thickness would be measured in. Centimeters or meters or millimeters or something like that. So it doesn't specify, actually it does specify, it wants it in millimeters. So we got to add one more step. Looking at our metric conversion factors, we find that 1 meter is equal to 100 centimeters and that also 1 meter is equal to 1,000 millimeters. We could put that in as 2 separate steps, but because they're equal to each other, 100 centimeters is equal to 1,000 millimeters, so we want the centimeters to cancel. So we put the 100 centimeters on the bottom and we put the 1,000 millimeters on the top. The centimeters cancel out, and we can also cancel out numbers that are on the top and bottom. So if they cancel, you can cancel them out. So if we take 100 and we cancel that out of the 1,000, then we're left with 10 on the top. So when we take 1.02 divided by 10.50, get our answer, divide that answer by 5.08, get our answer, divide that answer by 45.72, then take that answer and multiply by 10, we get 0.004183 millimeters. Now there's several ways that you can solve this. You can take everything on the top, multiply it together, take everything on the bottom, multiply it together, then take the top, divide by the bottom. Or you can multiply everything on the top together, then go back and divide, each thing individually, divide by what's on the bottom. The last step is to figure out our number of sig figs. Our significant figures in 1.02, that has 3 sig figs, 10.50 has 4, 508 has 3, 45.72 has 4, and then our conversion factors, remember, those are true by definition, so they have an infinite number of sig figs, so we ignore those. And so of those, the one with the least number of sig figs is 3, So that means our answer is going to be good to 3 sig figs. Now, we have to remember that leading zeros are never significant, so we don't start counting until we get to the 4. And so once we're at the 4, we count over 3. 1, 2, 3. So 8 is going to be our last sig fig. We're going to round. We're going to look at the number to the right of that to see if we round up, round down, or round to make it even. The 3 is less than 5, so that tells us that we round down, which basically means we just chop it off. So we end up with 0.00418 millimeters. Now you'll notice that we didn't add a 0 back into place for that 3, because 1, adding zeros to the end of this does not change the size of the number, but it does change the number of significant figures because there's a decimal point. And if they're on the right side of non-zero numbers, that makes them trailing zeros, and trailing zeros are significant if there's a decimal point.